Okay, so the first thing is that I'm gonna add a node or a program here. I'm gonna put it here, and I'm gonna rename it as, um, let's call it study data. So basically, this part is to prepare the study data. All right, so inside, what are we gonna do? The first thing we are going to do is to um, is to get some statistics about this the raw data. So we're gonna the first thing is, for example, we want to know that for in the hospital records, um, what is the earliest admission date, and what is the latest discharge date, and stuff like that, so that we can have an idea on the data range. So to do that, we can use a procedure. It's called proc means, right? Proc means. So this one is basically proc means is not only that it can give us the means um, of a variable, it can also give us the minimum value, the max value, which is in this setting. It's about the date, it's the earliest, and the latest the date. So I'm gonna I'm gonna step back and talk about the syntax, how to find the right syntax of this proc means. I have sent you guys an email in which there are a bunch of resources that we can use. So the first is the book called The Little Sas. This is a very good one. It's very easy to read and understand. And the second is that you can always check the online resources from the SAS official website. So I also provide the syntax here. The other two is one is called alexjensen.com. It is so there are a lot of examples and tutorials there. The other good site is called the UCLA website. So to search for these websites, it's very simple. You just go to Google and search, for example, search for the SAS 9.3 proc means. So why I put 9.3? I know that most of us are in 9.4. Actually, the university edition is based on 9.4. But for SAS, the best version of their tutorial files are saved in 9.3. So if you go to 9.4, it is not that good, it's confusing, but the 9.3 version is very good. And for most of the procedures we're going to use, the contents, the options are the same. So it's better to check that. For example, if you type this, it will pop up the official site is going to talk about everything about this proc mean. And if you go inside, you can see that it's going to tell you the syntax, and it's also going to tell you the concepts and the principles behind that. And also, it provides a lot of examples. So this is from the SAS website. The other is that if you go to the lexjensen.com, you will find a lot of tutorial materials. For example, like this one is about how to use the proc means. The other example is like if you go to UCLA, then you will also have this data. So most of the examples they're going to provide the sample data. So that is quite handy. You just copy and follow the steps one by one, and will to learn the syntax. Okay, so now let's go back and talk about this proc means. So what we want to know here, the first thing we want to know is that we want to know, we want to check the earliest and the latest main date and discharge date. Right. So these are the things we want to do, and we put it as a comment. Um, so by the way, it's a very good habit to put as much comment as you can have, because later, after a while, you're gonna forget why you took this step. So it's better to go back and it's better to add comments from time to time so that you remind yourself that if you go back, you still can pick up why you made it step. All right, so the context is like this. So we're going to have the source data. And we're going to let us, so for example, we're going to use the raw hospital data. Okay, so these are, you select the source hospital. And about what? So we want to know something about the dates, about the admission date, and also about the discharge date. Right. So these are the things we want to know. But what we want to know about the admin date and discharge date. So we want to know the number of observations in a hospital file. We also want to know, for example, the missing, so the number of records with the missing value there. And we want to know the earliest date, which is the main value here, and the latest date, which is the last. So that's it. That's the syntax. So we're going to select all of that and run. Well, so as I said, the first thing you should do is that, well, despite that the SAS is going to automatically switch to the result, the first thing you should do is go to the log and make sure that there is no errors, there is no warnings. All right. So, and then let's go back to result. So the result is like this. I'm going to enlarge it a bit. It says that you ask for the variables of admin date and discharge date. And in total, in this hospital file, each of this variable are seen in 2004 records. This is the total number of records. But four of them, there may not be the same record, but four of the records are missing the admission date, and four of them are missing discharge date. And then the earliest date is in a very strange number. So this part is very difficult to understand. So why the dates are in this kind of numbers? It doesn't make any sense in terms of the date values. So this is because SAS has used a different, very strange way to record the dates. So the date value is like this. So it has, SAS is going to have an anchor date, which is 1960, January the 1st, 1960. So that is the date. Well, it was reported that that was the date that SAS was born, but I doubt it's not. It cannot be that they just kick off or launch the SAS in the middle of the night. But anyways, they're going to use this as the anchor date. So all the date-time values are the distance in seconds between the interested date and that anchoring date. So in this case, let's say that if it is April the 1st, 2001, and it's going to calculate the difference between these two in seconds. So that's why we see this large number. So this is the date time value. In other case, that it can also be a date value. So if it is a date value, then it's going to check the difference in days. For example, this is going to check the difference in days. So that's how SAS is going to calculate the dates. The problem here is that when we use the mean procedure, it's going to tell us, actually this is the second since 1960, January the 1st in 1960 in seconds. But this one is very hard to read, right? So um, unfortunately, the Sas means does not provide a better way to tell us the dates. So we'll have to use a different one. And this different one is called proctabulate. Right? So we're going to use a second procedure. It's called proctabulate. Proctabulate is very powerful. It can make very flexible tables. Okay, so it is always like that. Yeah. So like as I said, it's better to have a lot of comments. Let's say alternative ways to check dates with proper format. Okay, format. All right. So these are the reason why we're going to use this tablet. All right. So again, you have to tell the source data. In this case, it's the raw hospital. And then the syntax is that again, you're going to tell the program what values you are looking at, or what variables are you interested in. So in our case, it is the main and discharge state. So the next is that to build a table. So to build a table, you just say table. Okay. So this will be the um, the same sentence, but in SAS, you can put one sentence in different lines. It doesn't matter. It's going to check that it starts from the statement and it has to be ended with a semicolon. So as long as it is with a bit before the semicolon, it's going to treat it as the same line. So what should we say in this table? The first is that we should define the rows. So we're going to define the rows. Okay. So I'm going to put that as a comment. And the rows will be the main date and discharge date. So what do we mean here? So what we mean here is that we need to list out the admin date and discharge date in separate rows, right? So it's similar to what we did in the means procedure. We want to list out these variables in separate rows. And then we're going to have a column. I know it's called a comma. Right? It's a comma. So, and after this comma, we're going to define the columns. We're going to define the columns. So what are in the columns? The columns are the measures we want to have as we had in this mean. So we want to have the number of observation, the number of missing, and the earlier and the latest date. So again, we're going to have, for example, we're going to have in missing. All right. So we're going to, let's just stop here and try. So this time, it should give us a table similar to the one we have from proc means, but it's going to have this part without the min and max. So let's just try it. Okay, so we have this, and so the dates are in separate rows, and we have this. So the next thing is that we're going to carry on because we also want to have two additional columns, which is the min and max. But wait a minute, this time we don't want it to be displayed in number of seconds, right? So we're gonna wrap that and say that, so for these two, both of these two, all right, so we want to have a format. F stands for format, and the format is date, time, 20. So now let's rerun this line. Yeah, so it's going to tell us that, okay, so now you have the dates, you have the numbers, and you have the earliest and the latest dates um, in a correct format, right? So here I don't have any example of date format, but you get the idea, and later you can try by yourself. Okay, so this is the part to uh, to check the dates. So now we have some understanding about this data. We know that the data, it sounds like the data start from this date and it ends in this date, right? And also we know that there might be an issue because some of the values are missing. Okay, so the next question naturally is that we want to know, we want to check what are the missing, the records, missing dates, right? So from the summary, we know that there are 4 records missing, uh, missing the main date, and 4 missing the discharge date. So we want to know that. So what we can do is we can have a conditional data step, which is just to slice out the data uh, from the raw data. So what we can do is we can start a new data. Let's just call it test2. We're gonna set raw data. So basically, we're gonna read the data from the raw data. But we don't want to have all of them. We just want to have those either with the main date. Oh, sorry. So yeah, admin date is missing. So missing in the numeric missing is a dot. So in the discharge date, oh, it is missing. Sorry. So this is a wrong logic. We should say or. So basically, we want to see that what are the missing, what are the records with the missing data. Either it is missing for the admin date or missing for the discharge date. And let's get it run. It sounds like I have a problem here because, oh, it's the wrong type because the color is different. It should say data. So basically, this is that we're going to generate a data set called test2. Right? And in this test2, we're only going to keep those with a missing value. We're going to run this part. All right, so first let's go to the log and to check if there is anything wrong. There's nothing is wrong. So then we're going to go back and we can view this data here. We can see that, well, for these records, it sounds like lots of things are missing. Basically, there is nothing there. And if you check the dates, some are missing the discharge date, some are missing the admission date. So now we have checked this data and we know that that these are the dates that these are the records with a missing value. So conversely, we can say that, or if we select the record without a missing data, what are the will be? So we can say that what are the records without a missing data? It's the flip side of this. So let's say that we're going to have data test 3 set get the same raw file. So this time we're going to say uh, if the admin date is not, this means not equal, right? And the discharge date is not equal to missing. And we're going to have it run. So this time we're going to have more records. Remember that in total we have 2,004 records, and in which like there are 8 records are missing with some missing data. So if we exclude, so in total we have 2,008 observations, in which that 2004 has an admission data, 2004 has have a discharge date. So if we exclude those with the missing dates or admission date and discharge date, we have 2,000 observations. So these data sets are clean because it does not have missing data in admission. So in reality, we should check all the records and understand, all the columns, and understand for each column how many records are missing of that value, stuff like that. That's very important because somehow we're going to make a decision. If it is like in this case, the number of records with missing data is minimal, then we can exclude them. Well, if we have like sometimes we don't have like 50% of records with a missing value, and in that case we have to think about a different strategy. So this step is very important. Okay, now, so in this simple case, I only said that the missing values are in these 2 columns. The others are fine. So in other words, that if the records does not have a missing value in these 2 columns, it won't have a missing value. This is just a setting in my dummy data. So based on that, we're going to do a tablet again. And this time we're going to say that if we exclude the admission or discharge date, what are the earliest and the latest date looks like. So let's say that check the day and after excluding records with missing values, missing dates, specific. Okay, so we have this comment, and then we are gonna have the tablet, proc tablet again. At this time, because I already have a demo above, so I'm just make it concise. So I'm gonna have a data test 3 here. Basically, it's the same thing, just to use a different source of data. So we're gonna get it run. So we can see that actually without the missing values, we will have the earliest date of this and the latest date of this. So same for the discharge date. So basically that means that if we have, from the raw data, if we have a condition to say that we are only going to include the records between March the 1st and April the 30th, or the May the 29th, then we're good. So nothing will be missing. All right. So this is very much data specific. This only applies in this situation. But for your real case, it might be different. But you get the idea. This is to basically to introduce the concept that you should first exclude those missing data, and the second is that you should consider the data start and end period. All right. So with this. Again, we can go and check. So we can check the test three. So I would be curious to see that where is this test three data set, because remember this one is basically the data was created in the work directory, which is the temporary directory, right? So I want to see that physically where is this work directory. So I can use this data set and check the contents of the data set, and it's going to have a descriptive part. It's going to tell us that in the source, where is the folder of this work directory. So this one uh, is quite important, I would say. You see that this data set, this one gives the full address of this data set. The part before the file name is the physical folder that we have for this directory. But sometimes, the system is going to blow up. And if you're fortunate enough that uh, the SAS Studio is still there. It's just that your SAS application is broken down. So in that case, you might save back your files saved in this temp directory. So I'm not gonna talk about that, but in case that something unfortunately happened, then maybe you can seek that, and you can Google to find the solution for that to save the data back. All right. So now, because we know that the data, if we set a data start and end period, then we are pretty safe that we're going to include most of the data. So the next thing is that we're gonna select data for hospital records within the um, data period. Let's call it the data period. So as we said that, well, if we have a test 4 here from the raw data set, if we select the admin date and discharge date between a period, which in this case, if we select only those within 2007, then it seems that we are safe. Right? So we can apply these conditions to select the data within 2007. So here there are two things that first let's just run it. So there are two things here. Um, let's go back to the code. It sounds like it's all right. So the two things here. The first is that uh, this time it is different. I use where instead of if. So where and if they all work for conditions to set the conditions. But they have different syntax. For example, in where you can say between and then, but in if you cannot say that. Well, they also work in different mechanisms. In brief, the well is more efficient. It's going to be faster. Um, but it has its own limitations. Sometimes it does not work because it has a special requirement for syntax. But anyway, so I'm just want to show you that for conditions, actually, you can choose different ways. So in this case, I'm going to use where. The other is that if you want to make an expression to represent a date, you're going to do it in this way. So the first is that you're going to wrap a string and end it with a key to indicate that it is a date value. And inside, you're going to put that in the format of um, DD, MMM, and then yeah. So in that format, it will be recognized. There are also other types of format, but I think for the dates, if you stick in that way, that's good enough for you. So the other is that remember the admission and discharge dates are not in the format of date, but they are all in the format of date times. So their values are the number of seconds instead of number of days to that anchoring date of January the 1st, 1960. So in this case, we need to transform the admission date from the date time value to date value. So the function to do that is called the date part. So basically, it's quite straightforward. It says that just get the date part of that date time value, and that becomes a date, and that will be counted by dates, and that date should be between this time period. All right, so this is basically what we did in this step. So the result is the same layout. And if we check the log, so originally we have 2000, right? 2000, which has, um, uh, just check the code again. Set, whatever. So the test 4 is going to have a 2000 observations. There is something strange here. I'm going to check it later. It should have 2008 observations. Oh, I know what has happened. Yeah. So that thing is strange, right? Because previously we have seen that in this raw hospital, it should have 2008 records, right? But here, if you look at the note, it says that there were 2,000 observations from the raw data set. So that means that actually not all of the observations were read from the original data set. So 8 records were not read. So why is that? So this is because this time we used the where instead of if. So the where is that if you use where instead of if, so all the records not satisfying these conditions won't be read from the original data set. So that's why I said that it's more efficient because even at the beginning, it doesn't even bother to read those records not satisfying the conditions. So that's why it is more efficient. All right. So anyways, the result has 2,000 observations, and it seems that those now missing records are all kept in this test of 4. So now we have a quite clean data set, right? So this data set is cleaned, and we can. The next is that we can save it as the final data set. All right, so we're gonna save the data records within interest within the data period into the final data set. I just received a note here. Carl, is that fine? Can you hear me? Is there any problem that you cannot hear me?
I can hear you.
Okay. All right, so let's carry on. So now we're going to save the records. And now because it is the final data set, we should not save it in this work directory, which is temporary. We should save it into a permanent library. But here, what we have is the S, which is for source data. So I'm gonna go ahead and create another library, and I'm gonna call that um, gonna call that T for target, and then I'm gonna have I'm gonna have the the physical location of that T there. So where should I put this target files? Remember that previously we have this input and we have this output folders that we already created. And it's in this output, we have the result and report. This result is for result SAS data set, and this report is for the future Excel files, those reports. So let's put it, let's assign the T to this results folder. So to do so, we're gonna right click to have the property, and in the property, we can have the physical location of that folder. We're gonna select and copy that, and we're gonna put it here. Okay. So, oh, by the way, so by far I have done a lot of coding. It's better to save it. Okay, so I'm gonna press Control S to save it. All right, so then let's run this line to create the T library. Okay, so it says it is successfully created. And if we go to the library, we can check that, okay, so the T has already been assigned. And then we're going to save the final data set to this T library. So what are we going to call that? So let's call that um, t.data.hospital. All right. So the original one in the source file is called the raw hospital. Now, because we've selected the data between the data periods, we're going to call that the data for hospital. So these are the data that we're going to use for the hospital records. So, and actually the source set is the same as the S4. We just copy that again to a permanent library. Let's just run this part. And check the log. Yeah, so it is copied there. So if you go to the T library and refresh it, then you will see that the data hospital has been saved there. All right, so that's pretty much that I'm gonna show you in this part to check the raw hospital data and to select the data from select the data within a certain data period, and then we can set up a permanent library called the T and save the final data set into that T library. So this is for the hospital part. So later as an exercise, you can do the pharmacy file because I also set up some um, missing records there for you to check. Did I? I can't remember. Anyway, you can check that. So basically, it's the same principle. I just copy the code here, um, so that you can compare your approach. It may not be the same anyway. You can compare the same thing, the code I have. All right, so before we move to the next section, uh, I I'm gonna talk about uh, a special type of variable that is gonna be used in this file. Um, so it's like this. So for example, uh, remember that we have the lib name of t to set up a permanent library. So imagine that if we are not going to do it here, right? So we're going to move, so we're going to do it. Let's go back to the flow chart. So we're going to move that into the settings. So remember that in the settings, we've set the libraries for the source data. And we are also going to set the library for the target data or the result data. We're going to put it there, right? So that will make all the settings done in this program. Right? So later, if we want to change the folders, it's easier to change in one program instead of running into different programs to set it. So because we've moved it there and we don't have to keep it here, I'm going to comment this part because it's already set. So this is the trick usually I applied in my coding because I always want to put all the settings in the setting program. So later it's more flexible for me to adjust and change there. Right. So the same principle is that, let's go back to this study data. So remember that we set a data period. We say that we are only going to include the data within a certain period, right? And it is in this step when we make this test 4, we say that it's better to have the data between this step. All right. So let's imagine that we're going to call this date. We're going to call this date the data start date. Right? So let's say that this is called the data start date. Right? Data start date is this. So actually, you can name it like this. It doesn't matter. It's not case sensitive, so you can name the data set like this. It's easy to use, right? So let's also call this date the data and date. So the data and date is this, right? So imagine that we're going to have two nicknames for that. Um, then we can replace these values with two nicknames. So why would we do that? I'm going to explain that later. So to let Sas have the nickname, the syntax is we're going to put a percentage sign and then let, and now let this data equals this, and with a semicolon. So it's the same trick that for this end date, we're going to put an expression here. So this is the way to actually put a nickname for that. So now these two are actually, it sounds like a parameter, right? So let's just, I'm going to keep this part, but I'm just going to copy that, comment this part. I'm just going to repeat this part again, but this time, instead of these fixed dates, I'm going to use the parameter. So this should be data stat date. Right. But to indicate that it's a parameter, you have to put in an imp sign before. So the data end date is the same thing that we're gonna replace that with the data end date. So it's the same trick that for the second for the slide. It's the same. So that way we have replaced a fixed date with a parameter. In such parameter, it's called uh, macro variable, or it's called the parameters or the nicknames, whatever. All right. But this is a special name. It's called the macro variables. So this part becomes using macro variables to define data start and end date. All right. So if you run this part, it's going to do the same trick to select the records within the interested date period. It's the same thing. So if you go to the log, everything is fine. So uh, why would we do this? Because just as we did before for this lib name, and because we are using the parameters, we can move these parameters to the setting part. So I'm going to comment that. And I'm going to go back to that settings and put it there. So these parameters can be used across different programs as long as the Sas is open. So we can put it here, and let's call it define study related dates. Right? Okay. So we're gonna put it here. So again, these kind of setting things are gonna be in the setting program, right? So this is gonna make our coding more flexible because later, if I change my mind, if I want to choose a different start and end period, I just have to change it here instead of running into the different programs. So uh, by this time, I'm just gonna show you that eventually this is in Sas Enterprise Guide is the similar one that involves all the programs that we're going to cover in this tutorial. So you can see that there are a lot of different programs. And I can tell you that in reality, you might have 10 times of that much programs. So it will be so difficult to find out where in which program that you have to change the date. So it's better to put all of these changes, these settings into all of the definitions or adjustments or the settings, whatever, into this program so that later you can always find the changes there. Okay, so now because we have set it here and in the study data, we don't have to set it again. I think I have commented that. Right. Okay. So basically, that's what I am going to cover for this part. And this part is to create the study data. So if you go through this in the exercise, you will have the farm data set. So I think I'm gonna stop here for a while because I'm gonna stop the recording and make a video file. Then maybe I'm gonna stop for like 5 to 10 minutes and restart again. Find the recording.